Welcome to the Explainer. So if you work with data, you know the absolute headache of manual forecasting. I mean, we've all been there, right? Staring at endless spreadsheets, tweaking statistical parameters forever, and basically trying to guess the future based on the past. It's tedious, it is incredibly time-consuming. Well, today, we're putting an end to that headache. We are going to build the ultimate solution, an automated, intelligent, end-to-end forecasting pipeline. And we're going to do it using a really powerful tool called TimeCouplet.
Okay, let's dive right into this. Just imagine for a second, what if your forecasting pipeline could actually explain its own predictions? Imagine not just getting a chart full of squiggly lines, but a system that translates those complex numbers into plain, actionable English. You know, a system that tells you exactly why a spike happened and what model works best. That is exactly what we're going to achieve today.
Here is our architectural blueprint for today. We're going to build this chronologically. First, setting up the pipeline. Second, configuring the models. Third, testing and ranking those models. Fourth, forecasting and finding anomalies. And finally, number 5, AI agents and insights.
Let's kick things off with Section 1, setting up the pipeline, laying the foundation.
So our initial build steps start with installing TimeCouplet. Now I really want to highlight a critical detail here. Pinning the NumPy and SciPy versions. In data science jargon, pinning simply means we're forcing the system to use specific, compatible versions of these libraries. We do this to prevent messy binary conflicts from totally crashing our environment before we even begin. It's just good basic pipeline hygiene. Step 2, we load in our real-world data, the classic air passengers dataset, right alongside a synthetic dataset where we've intentionally injected some wild anomalies. We do that to see if our system can actually catch them later. And finally, in Step 3, we lock in our monthly frequency and tell the pipeline exactly how far into the future we want to predict. That's our horizon.
Moving right along to Section 2, configuring the models, installing the engine.
And this brilliantly illustrates the real power of TimeCouplet. On one side, we've got traditional statistical and profit models. These are the tried and true classics of time series analysis. But on the other side, we have modern foundation models, like Chronos and the GPU-based Times FM. Now, in a typical workflow, testing these drastically different models against each other, it requires writing entirely different sets of complex code. It's a huge pain. But here, they are literally all managed under one single unified TimeCouplet forecaster interface. It's kind of like having a garage where parts from a classic vintage car and a modern spaceship both fit perfectly into the exact same engine block.
All right, Section 3, testing and ranking models, the stress test.
To be completely objective here, the pipeline runs a rolling cross-validation. Basically, this means it tests each model across 3 different historical time windows to see how accurately they would have predicted the past. It scores them on metrics like MAE, maybe, and most importantly, RMSE, root mean squared error. The model with the lowest root mean squared error takes the crown. It's an automated, completely data-driven competition where the most accurate model automatically wins the right to generate our final predictions. Absolutely no guessing required.
That brings us to Section 4, forecasting and finding anomalies, the output.
Before we actually look at the results, let's quickly clarify an important concept, probabilistic forecast. These are future trajectory predictions that map out 80% and 95% prediction intervals to quantify the range of uncertainty. So the crucial point here is that a point forecast alone, just drawing a single definitive line into the future, it just isn't enough in the real world. Quantifying our uncertainty, really knowing the absolute best and worst-case scenarios within a certain probability, is just as important as the point forecast itself if we want to make safe business decisions.
Now the pipeline goes to work basically acting like a brilliant data detective. First, it plots our observed historical data right alongside our newly generated future predictions, making it super easy to visually compare them. But it doesn't stop there. Remember those synthetic irregularities we intentionally injected back in Step 1? Well, the pipeline scans the entire panel dataset hunting for them and successfully visualizes the flagged anomaly spikes right in our synthetic series. So it tells us not just what the future looks like, but exactly where the past behaved weirdly.
And our final stop, Section 5, AI agents and insights, the brain.
I'd like you to meet the TimePilot LLM agent. This is an optional intelligence layer powered by advanced AI models from OpenAI or Anthropic. What this agent does is bridge the massive gap between raw data science and business-ready communication. It translates all those complex numerical forecasts, the error metrics, and the anomaly flags into accessible, plain English analytical responses. You really don't have to decipher the math anymore. You can literally just ask the agent what the data means. It's a total game changer.
Now, what's really interesting about this is that the agent is not just a passive reader of data. It actively selects the best model and critically evaluates it against the baseline. In this case, a basic seasonal naive model. It's doing active critical thinking for us. It ensures that our fancy, complex foundation model is actually providing more value than a simple baseline guess. This guarantees that your forecasting insights are genuinely robust before you ever present them to your stakeholders.
Wow. Okay, let's review the massive amount of ground we've covered in this explainer. Our blueprint is fully built. We started with data preparation and environment setup, securely pinning our dependencies. We moved on to model configuration, seamlessly bridging traditional statistics with cutting-edge foundation models under one single roof. We stress-tested them using cross-validation to objectively pick a winner. We plotted probabilistic forecasts and hunted down anomalies like a detective. And finally, we wrapped the whole shebang in an AI agent to deliver plain English insights. We successfully transformed dense code and raw data into a unified, intelligent forecasting workflow.
Which brings us to our final thought for today. If your forecasting pipeline can automatically build itself, rigorously test its own models, and then clearly explain its own predictions to you in plain English, what complex decisions will you trust it to make next? The possibilities for your data are literally endless. Thanks so much for joining me for this explainer. I really hope this blueprint empowers you to tackle your own forecasting challenges. Keep learning, and I'll see you next time.